All right, guys, well done for sticking it through. You are now on day 5 of 100 Days of Code. And today I've got a fun project for you. And the inspiration for the project comes from the fact that all sorts of companies seem to be getting hacked these days. Everything from Ashley Madison to Verizon, everybody seems to be really bad at keeping your password safe. So, how can we make sure that these hackers who are in hoodies and wearing face masks don't get to you and your account? I also don't know why hackers are always portrayed like this. I mean, they're in their own house, they don't have to hide their face. But at least they're conscious of not spreading germs and staying warm, so that's good. But how do these hackers get into your account, anyways? Well, one of the most common reasons is password reuse, using the same password on 20 different sites from Google to Facebook to Skype to Spotify to all the random services that we sign up to. The problem is that when one of these sites get hacked, then the email and password combination you used to sign up is compromised. So all a hacker has to do is try out those credentials on a bunch of other websites and see if they work. So, how would you know if your email and password is on a database somewhere? You can head over to haveibeenpwned.com, notice the spelling there, and type in your email to see if it was involved in a website that had been hacked. So let's try an email here, elon@tesla.com. And it tells us, oh no, it seems like this email has been pawned. And these were the websites which got hacked, potentially leaking this email and its associated password. I actually recommend you to try out your own email addresses right now and see which services you signed up to have been compromised. But if you want better security, then you'll actually need unique passwords for each and every website. And they should really be strong passwords, not 123456 or QWERTY. If I just called out your password, please change it. Now, what we're going to be building is exactly that. We're going to be building a password generator, something that's going to generate strong passwords with letters and symbols and numbers. First, it asks us how many letters would you like in your password? I would like 12. How many symbols would you like? I would like 2. And I would also like 2 numbers in my password. And then I hit enter and it gives me the password that it has generated with 2 symbols, 2 numbers, and 12 letters. So that's a pretty strong looking password, if you ask me. Now I can use this and update my passwords to something very strong and very secure. So this is what we'll be building by the end of today. But in order to do it, we first need to learn some new skills and new concepts. So head over to the next lesson and let's get started. The first topic I want to talk about today is the concept of loops, things that have to happen over and over and over again. The first type of loop I want to introduce you to is something called the for loop. And it can be used really easily in combination with something we learned in yesterday's lessons, which is lists. By using a for loop like this, we can go through each item in a list and perform some action with each individual item. So let's try it out in practice. In order to follow along, go ahead and fork the day 5 start REPL. And once I've explained the concept, then I want you to try it out yourself. But first, let's say we had a list called fruits, and it contained 3 items, apple, peach, and pear. If we wanted to access each item in this list individually and print it out one by one, then we would use a for loop. So we start out with the keyword for, and then we give a name to a single item. So in this case, we might call it fruit. And then we use the in keyword, and finally the list that we want to loop through, which is our fruits here. Now we cap it off with a colon, and we go on to the next line and notice how it's indented there. Now I'm going to go ahead and print the value of each of the fruit variables. And if I run this code, you'll see that it loops through my list of fruits, and for each of the fruits inside the list, it prints it out into the console. apple, peach, pear in that order. Now, the important thing to realize here is that basically you can imagine that behind the scenes, what this code is doing is it's taking this list of fruits and it's assigning a variable name, fruit, to each of them. So the first time this runs, fruit is equal to apple. The second time this runs, fruit is equal to peach. And we can see this even more clearly if you run it through the Thonny IDE, which I told you about at the beginning of the course. Now, if I go ahead and click on the debug icon and I step into each of the steps, you can see first it establishes that we have a list of 3 strings, apple, peach, pear, and then we go into the for loop. Now, notice on the right here, I've got all the variables being accounted for. And the first one it's noticed is the variable fruits, which holds a list of strings. Now, as I continue into the for loop, notice how it's going to look through this list of fruits, and it's going to assign the variable name fruit to each of the items, starting from the first one, apple. So now, by the time it's reached line 3, we've already got this variable called fruit that's been assigned to the value of apple. And so at this point, printing out the value of this fruit, it's obviously going to print out apple, as you'll see in the next step. There we go. Now, once I'm done here, then it's going to loop back to the start of the for loop. And now this variable fruit is going to be assigned to the next value inside the list of fruits. So now notice how the variable fruit is attached to the value peach. And then it continues this and so on and so forth until it prints out each one of the fruits. And this really emphasizes the most important aspect of loops. The loop allows us to execute the same line of code multiple times. In this case, we're executing the print statement 3 times, but our for loop isn't limited to just executing a single statement. We don't just have to print out the name of an item in the list. We can execute a whole block of statements multiple times, and we can do many things inside this for loop, and by inside, I mean indented. So let's say that in addition to printing out the fruit, I'm going to write another print statement, and I'm going to not only print out the name of the fruit, but I'm also going to say fruit plus space plus pie. So when I run this code, what do you think will happen? Well, it prints out apple, and then it prints out apple plus pie. And then it goes back to the start and it assigns the variable fruit to the next item, peach, peach pie, pear, pear pie. So this is how we can implement a simple for loop that loops through a list and assigns a variable name to each of the items in the list in order. And then inside the for loop, after the colon, after some indentation, we can do something with that temporary variable for each of the items. Now, I've been talking a lot about the concept of being inside a for loop versus being outside a for loop. And this is really, really important. Whenever you see a colon, say in our if statements that we saw previously, or the for loop that we're using here, the indentation is really, really important, because if it's indented, then it means that it's inside the for loop, and these instructions will get carried out for as many times as the for loop will need to repeat. Now, if I decided that I wanted to, say, print my fruits, so my list of fruits up here, and I put it inside my for loop, so indented after the for loop, then as you can imagine, it's going to print that for as many times as the loop runs, which is going to be 3 because there's 3 items in our list. Now, if I had indented that back to the beginning, so now it's no longer inside the for loop, then it's only going to print once, and it's going to print it after the for loop is done. So notice how it's doing the whole apple, apple pie, etc. And then once the loop is finished, then it jumps to the next line and carries out this instruction. So the indentation is really, really important, and you have to be really careful with this. Have a play around with this code And if you're still struggling to see how it works, then move the code over to Thonny and step through each step one at a time and see how it works. But I hope you're starting to see how loops are really handy at executing an instruction over and over and over again, getting the computer to save us time and energy. A really good example of when loops would come in really handy is, you know how Bart Simpson gets punished and has to write out a sentence over and over again on the blackboard? Well, if only Bart was a programmer, then he would be able to use loops to do this, and he would be able to chill in the corner. Now, once you're happy with this type of for loop, then head over to the next lesson where I've got a coding exercise that's going to put your knowledge to the test. All right, so I'll see you there. Head over to day 5.1, the average height exercise. Now, the instructions are that you're going to write a program that's going to calculate the average student height from a list of heights. So, for example, let's say we had a list of student heights that looks something like this. Then you're going to be using a for loop, hopefully, to figure out the average. And the average can be calculated by adding up everybody's height and then dividing it by the number of students inside the list. And then I want you to round it to the nearest whole number. Now, notice how we've got some starting code here, and this is just for us to be able to input a list of student heights for testing and see if your code actually works. So if you go ahead and run the code, then you'll notice that it asks you for a list of student heights, and the input is going to look something like this. They're just going to be a bunch of numbers separated by a space. So if I go ahead and paste that in there, then I hit enter, then notice how this line on line 5 is going to print it out just as a normal list full of numbers. Now, Python has some really useful functions, as we've seen. We've seen that we could use the len function to calculate the size of a particular list. So if I go ahead and print my length of student heights, and then I paste my student heights in here, then you can see that I get 5 printed by calculating the number of items in here. Now, Python also has something called sum, and this gives us the total of all the items from a list. So in this case, all of these added up would be 857. Now, your job, though, is to figure out how these functions actually work under the hood. In order to fully complete this challenge, you can't use the len function or the sum function. Instead, you have to figure out another way through the use of for loops where you can add each of the items inside the list together, and you can use a for loop to figure out how many items there are in this list and use that to calculate the average. So you can't use either of these functions, and instead you have to rely on what you learned in the last lesson to complete this challenge. So have a think about it, and once you're ready, give that a go. Now, we know that we can't use either of these functions, the sum function or the length function, because if we could, then this challenge would be super easy and we would be able to calculate the average by getting the total height, by getting the sum of all the items inside student heights, and then we could calculate the number of students by using the length function to calculate the number of items inside the list, and then we would get the average height by dividing the total height by the number of students, and then we would be able to round this value off and print it out. But this, as you've noticed, doesn't use a single for loop, and the last thing we learnt about was a for loop. So this is definitely not the right way to solve the challenge. It works, but what I wanted you to do is to figure out how the sum and the len functions work under the hood. How is it actually implemented? And to do that, we have to use a for loop. So let's have a think about how we would first tackle this one, where we get the total of all the items inside student heights. So we basically want to add each of them together until we get the total. Now we can do this by simply using a for loop, as you've learned in the last lesson. So if we start off total height as 0, and then we write a for loop and we say for height in student heights, and then we add a colon, then now we're going to loop through each of the heights inside this list, and we're going to add it to our total height. So we can say total height equals previous value of total height plus height, or as you might remember, the shortened version of this is just total height plus equals each of the heights. So now we can go ahead and check whether if this worked by printing out the final value of total height. And notice how I'm doing it outside the loop by making sure that it's not indented like this. So let's run our code, and I'm going to paste in those numbers as the demo numbers, and then we get the value total height is 857, which if you take a calculator, you'll be able to verify it's exactly right. So now we've basically replicated how the sum function works. And now we can try and replicate how the len function works. We know that basically the len function figures out how many items are in a particular list. How can we do this using a for loop instead? Well, what if we do something similar to what we did above, where we start off the number of students as 0, and then we write a for loop for student in student heights, and inside our for loop, all that we do is we add 1 to our number of students each time our for loop runs. And if you remember from the last lesson, I said that the for loop will run for as many times as there are items inside the list. If there are 5 items inside the list, then the for loop is going to run 5 times, which means this line of code is going to be called 5 times, which means we add 5 to our number of students, and we end up with the total length of the list. So now let's go ahead and print this number of students out and run our code. And I'm going to paste in the same 5 numbers in the example input. And you can see that the first value that comes out is my total height. The second value is the length of the list, the number of items in the list, which is 5. We can verify that. And the final one is the average, which matches up with the example output. So now let's get rid of our print statements by commenting them out. Now, one of the things I want to point out to you that you might have noticed is that in the first for loop, even though we're looping through the same list, I've called each of the items height, and in the second for loop, I've called them students. Now, whatever we name each of the items inside the list, it's totally up to you. You could call it H, you could call it X, you could call it basically anything you want, as long as you are consistent with using it inside the for loop. So if you're calling each of the items inside the list H, then when you're using it inside the for loop, when you're modifying it or doing something with it, then you're going to refer to it by the same name. Now, usually it's a good idea to give it the name which is the singular form of each of the items in the list. For example, previously we had a list of fruits, so each item was called fruit, the singular form. And in this case, we have a bunch of heights, so each of them I've called height. In the second for loop, I've decided to call each of the items a student. Now in this case, even though you have 2 for loops, you can call them the same thing. But sometimes I find it a little bit confusing to have the same name in 2 for loops. I prefer it this way, but it's totally up to you. Just follow the good practice of using a singular form of whatever is contained in a list when you write a for loop like this, and you'll have less trouble down the line. So now that you've gotten a taste for for loops, it's time to complete another challenge, which is going to stretch you a little bit further. Head over to day 5.2, highest score, and we're going to get a list of student scores. And it's a list of numbers again. The idea is that you're going to write some code that's going to output the highest score in the class. So you're going to look through this list using a for loop and figure out which of the scores inside the list is the highest value. Now, we can see pretty much at a glance that inside this list, 91 is the highest. But remember that when you test your code, you won't be able to see the input, so you won't be able to cheat that way. Instead, you have to do this using code. Now, just as in the last lesson, I mentioned that Python has some pretty useful functions that helps us do a lot of these commonly needed things very easily, such as the sum and the len functions. Well, in this case, there's actually something called the max function. So if we pass a list, let's say the student scores list, into a max function, and then I go ahead and print out the maximum value from my list of student scores. So let's run this code, and I'm going to use the example input, so a bunch of numbers separated by a space, and hit enter, and you can see it tells me that 91 is the highest value. Now there's also the min function, which basically will give me the lowest value inside a particular list, which in this case is 55, but that's too easy. I don't want you to use the max or the min functions. Instead, you have to use what you've learned about for loops to replicate the underlying functionality of this max function. Because people tend to use Python to do a lot of data manipulation, to do a lot of mathematical calculations, it has a lot of these convenient functions for you. But let's say you move to a different language and you work on something else, then these might not exist. So understanding the underlying logic and being able to write out the code using things that every programming language has, like the for loop, will mean that you will become a much, much better programmer in the process. So try and replicate the functionality of the max function, and the output should have the words, the highest score in the class is, colon, and then a space, and then the actual max value. So this is what should happen. Pause the video now and have a think about how you would write your code in order to get hold of the maximum value from a list. All right, so did you manage to complete this challenge? If not, and if you want to see how I do it, then continue watching along. The first thing we want to do is we probably want to get hold of each of the scores inside our list of student scores. So I'm going to write something like for score in student scores. So again, keeping that convention of singular from plural. Now inside the loop, what can I do? Now let's say I had a variable called highest score, and I'm going to start it off as 0. And then inside my loop, I can use an if statement to check, well, is the current score that I'm looping through greater than the highest score that I've got? Well, then if so, that means this current score should actually be the highest score. So I can set my highest score to equal, single equals means a sign, double equals means checking, remember? And this loop will continue running until I've checked through all the scores inside my student scores, and I've got the highest score stored inside this variable. So now I can go ahead and print the sentence. The highest score is this particular value. So I'm going to use an f string to insert my highest score variable inside here. And if I run my code and use this example input, then you can see it tells me the highest score in the class is 91, which matches exactly with the example output. Now, if you're at all confused about how this code works, then I recommend, again, pasting it into Thonny like this. So you've got a list of scores, and then you've got the code in the solution, and click on debug, and you can see how we actually step through each of these stages, where we start off with a highest score being equal to 0. So that's where it is. And then we continue into the loop where we go through each of the scores inside the student scores. So the first one is going to be 78. So now we've got this variable score which is tied to the value 78. And then we go and check if the score, which is 78, is greater than the highest score, which is 0. Well, that's obviously true, right? So if that's true, then it's going to carry out the next line of code, which is that the highest score is now equal to score. So now notice how this highest score variable is going to update to the first value because 78 is greater than 0. Now we go back to the start of the loop and we go to the next value, 65. And 65 is now checked against the highest score. Is 65 greater than 78? Well, no, that's not true. So this is false, and so the highest score is left alone. And we continue back to the next value. So now our score is equal to 89, and our highest score is still equal to 78. Is 89 greater than 78? Yes. So now we reset the highest score to the new value, which is 89. And it continues this loop until it gets to the end and it's found the highest value and it prints it out into the console. Play around with the debug and step through each of the stages to see how it works and compare it with what's happening with each of the variables on the right. This is a really, really useful way of wrapping your head around all of this complex looping and conditionals. And once you've understood everything that's going on, then you can continue to the next lesson where we're going to talk about another type of for loop, the for loop using a range operator. So for all of that and more, I'll see you on the next lesson.